Matej Semančík, and I'm an Android engineer at Futured. Futured is a mobile-first agency based in Brno. And also, I'm working with Betsys on their mobile application, and I'm part of the platform team. And this talk will be about results of our experiments with sharing the navigation in the Kotlin Multiplatform. This basically started as a effort a few months back. It was effort to share a presentation logic in our applications in KMM. And it turns out that when you get to the sharing the presentation logic, then sharing also navigation state is just one step, like the next step to it. And so it turns out that it actually works pretty good. This talk, like, what can you expect? This is gonna be about Android and iOS, and I'm gonna show, this is gonna be mostly focused on native UI. So what I'm gonna show is how can you share the navigation logic while using the native navigation components mainly on iOS, because this was really sorry, I'm nervous. Yeah, this was really important for our iOS colleagues, because when we came to them and we told them about our plan to share the navigation state in KMM, they told us that we must use the native Swift UI UIs. You know, so we started to work on it, and in the end we came up with a solution that uses navigation stack view from Swift UI, and I'm gonna show you it works pretty well. So first things first, how many iOS devs do we have here today? All right, and Android? Nice. I actually gave this same talk at Brno, at the start of this month at Brno, and the room was full of iOS guys, and I was super nervous because what I'm gonna show you, I wrote some Swift UI code, and it doesn't look really well. So at least there's not gonna be so many people to criticize my Swift UI code. All right. So if you want to share the navigation state in KMM, in Kotlin Multiplatform, we have to understand the core navigation principles for each platform. And what I had to do basically was to get familiar with the iOS side of the things. And for me as an Android engineer, it was really mind-blowing what the iOS can really do, because there are some really advanced navigation concepts you just don't get on Android. So let's look at some examples. What I'm going to show you here is our internal prototype application, which we developed over a few months, that we iterated on, and we basically developed this. This application has fully shared presentation logic and navigation logic, so everything is shared except for the UI. So this is quite basic example. Both platforms can do basic push and pop navigation, right? But on iOS, it gets really interesting, because if you use the native navigation stack or navigation view or whatever on iOS, you get this cool feature when you hold the finger on the back button, and you can pop multiple levels back, which we just don't get on Android, right? So this was the first thing I learned, that okay, we need to account for this when we do it in KMM. Then you got system overlays. Basically, these might be dialogues, models, alerts, whatever. This is quite common for both platforms. However, yeah, there are sheets. And the sheets are the big part of the iOS navigation side of things, because as you can see, the sheets on iOS are really integrated into the system. Like on Android, we get model bottom sheets from the material library, but on iOS, the sheets are really baked into the system. And you can see this nice animation that when the previous screen goes back, when you expand the sheet. And what's really interesting, or we just don't get that on Android, is that you can stack multiple sheets on top of each other. And when you do that, you can see like the system handles that layering for you with this nice animation. And like you can do this on Android. It looks like really ugly. So like we just don't do these things on Android, but it can be implemented, right? And you can see just how much integrated are sheets on iOS, because what you can do is you can embed another navigation inside the sheet. So when you combine that, you can stack multiple sheets on top of each other, and each of the sheets can have its own navigation. And so when I learned that, I came to my iOS colleagues with the first prototype saying, hey, I implemented some navigation. And he was like, are you serious? Like, look at this, we can do this. Like, and he showed me like this stacking of the sheets and embedded navigation. And I was like, okay, this is not going to work. I mean, I have to go back and try again. So yeah, this is like pure madness, and we managed to get it working in KMM. So now let's look at how we display navigation UIs on both platforms. In SwiftUI, we chose to go with the navigation stack. Navigation stack is the latest and greatest addition to SwiftUI in iOS 16. And as I said, it was a requirement from our colleagues, because we write our apps to be native. We want to have that native feel in our applications, and we just don't do like custom stuff. So basically, our iOS apps used to have like this navigation controller. I don't know how is it called on iOS, like what was the previous version. Then we had like the navigation view when SwiftUI came out, but now we are migrating to navigation stack. So we had to use navigation stack. Navigation stack, when you take that analogy to Android, navigation stack is something like Jetpack navigation component on Android, because the navigation stack handles the displaying and routing functionality for you, like it's built in. And you have to really use that if you want to get that nice functionality of having this long press on back button and the sheets and so on. You know, Apple is really strict with their design choices. They force you to do things, so yeah. In SwiftUI, like iOS devs will be familiar with this, but the way that the navigation stack syncs back the state to the underlying data structure that holds your stack or path is using the binding. So basically, this binding reads the navigation state, and this navigation state is displayed for you. However, if you perform a back navigation using swipe, or if you perform the back navigation using this back button callout, they call it, then this set method is going to call for you, and you are supposed to override your navigation stack, which you have there, basically. And this is really important, because then we are going to use it. We are going to hook into that binding when we write the shared navigation in KMM. In Jetpack Compose, you could use Jetpack navigation library, but this is really whack because it doesn't have animation, and I mean, like, you can write whatever you want in Jetpack Compose because it's so flexible. So let's just assume right now that we have some sort of navigation host, And it is really up to you how you handle the back navigation. You can catch the event and so on, so it's really easy. Yeah. So how we move this to KMM? I'm gonna go on the next slide. So what you want to basically do is to have some contract between your UI and your shared part. So you get the, you should basically define some shared navigation or some shared navigation stack or some data structure that you're gonna hold in the Kotlin part of the things. And then you have to define some contract callable from the UI which will perform mutations on that stack. So, when you look at the Swift UI side of things, you basically go from this to something like this. I know there's a lot of code. I'm gonna explain that a little bit later on, but the main takeaway is that you hook your binding, which is used in navigation stack view, into the Kotlin. So in the get function of this binding, you just read the path that is provided to you from the Kotlin. And in the set method, you have to, again, override the entire navigation path or navigation stack into the Kotlin, because what this set method really does is it provides for you the entire new array of your navigation path, which you should sync back into the Kotlin. In Compose, really easy from this to this. I mean, like, you just observe some state from Kotlin and then call your actions back to the Kotlin. But we are just starting. This is not enough. And it's not enough because sooner or later, when you start to go further with this, you will encounter some limitations. You want your navigation entries to be reactive to lifecycle. We don't have safe state handle. How do you even survive configuration changes? And how would you implement this madness, which I just showed you on iOS, these multiple sheets? And we could build yet another navigation framework, but why should we reinvent the wheel, right? There should be something already ready-made for us. And what we basically came to was this. Does somebody know this library? Hands up. 1, 2, 3, 4, 5. Nice. Right, so the Decompose is a Kotlin Multiplatform library which lets you implement these blocks of components set. I would read the description, but it's too long. Just read it. It basically lets you create a components which can have their own presentation logic and do stuff in Kotlin. So if you have some like screen, that screen might be your component, and this component inside might have some presentation logic. But what is important is that you can navigate between these components. These components can be stored on navigation stacks in Decompose. And Decompose actually provides you with some navigation APIs which lets you do this. These components are lifecycle aware, so there are like abstractions over Android lifecycles, over safe state handle. These components can have like objects inside that survive configuration changes. So it really opens you to a whole new world of possibilities if you decide to like implement your architecture in KMM and to share as much as possible, because you suddenly get that Android features like lifecycle and so on, and you get them in KMM. So what might be a component? Like it might be basically anything, but in context of this presentation, let's say that the component would be our screen, would be our model such as alert, dialog, sheet, whatever. Something that can be part of your navigation graph. Now let's look at the two main concepts of navigation at Decompose. Decompose provides the stack navigation and slot navigation. The stack navigation is basically used to stack your screens on top of each other, like deck of the cards. This is basically like the navigation concept we are all used to, because this concept is implemented both on Android and iOS. What would you do in Decompose? In the shared code would be that you create some sort of child stack, and that child stack would have a stack of some objects, so your components inside, and then you would have some navigator, which is just another thing in Decompose which lets you mutate that navigation stack. And so you get some built-in essential functions like push and pop while, but also what's really cool about Decompose is you can implement your custom transformations of the navigation stack. And this is really important because we can use this to implement an interop between the SwiftUI's navigation stack and the Decompose side of things. Now for the slot navigation, the API is very similar. It's almost the same, just with the difference that the slot navigation can just activate and deactivate component. And this is really useful for dialogues and sheets, like basically screen overlays that you can like activate and they appear and then you just dismiss them. So how would we tie it all together? Basically, how would you like create this child stack and show it in your UI? Well, first of all, you need some root component. And as I said, the component can be anything in Decompose, so you have like just declare it, right? You get your component, and I'm not gonna go into internals of how to use Decompose. You can look it up later because it's really big library. However, you create the component, and inside that component you will have your navigation stack of the children or some screens. And you can notice that there's this value object. This value object is provided to you by Decompose, and it is a Decompose way to provide an observable state to the UI. It's something like Kotlin's coroutines state flow. So basically, you can subscribe to that value from a UI, and you automatically get an update. So for Jetpack Compose, you get built-in extensions that lets you consume that value. And for the Swift UI, you can build your own, basically. It's really simple. I'm not going to show it. There's going to be a code after. But yeah, it follows the observer pattern, so you just like subscribe to it, and then you get updates, and then you unsubscribe when you feel suitable. So yeah, this is like the Compose class that lets you do this. And now, what's also implemented in the Compose, in Jetpack Compose extensions, is this children composable, which lets you display the navigation stack from the Compose. And you could, of course, implement your own composable that displays the current state of the stack. However, the Compose provides it for you, and you get built-in stuff like animation support and back handling and so on. So it is really like a handful to have this available, and it is customizable, of course. So on Android, we just don't have to care about anything, basically, if you are fine with using this. However, you can go deeper if you like. In Swift UI, this is going to be a little bit complicated, but bear with me. So the first screen of your stack in Swift UI, when you use the navigation stack view in Swift UI, the first thing that you display in that view has to be hard-coded. Basically, it is there because, like in iOS, the first thing in your app always has to be there. So basically, you just cannot swipe away the only thing you can do in iOS is go to the home screen or kill your app. So basically, what you need to do here is do not let the binding in Swift UI's navigation stack view. You just have to make this first view, your first screen, which is stored in Kotlin. You have to make it transparent to that to Swift UI. And this is just an example. I know this can be like written nicer, of course. You can move that logic to KMM and just provide the iOS navigation path or whatever. But it is important to know this. You just have to like make it transparent. The first child in a stack has to be transparent to the iOS. And so, as I said, there was this functionality of iOS where you have to the user should be able to pop multiple destinations back of the stack. And so you do this basically by implementing a custom transformation. So like I mentioned, you are provided a new path in this set method, and you have to sync back this path to the Kotlin side of things, and we can do this by implementing a custom transformation over the this is just an extension function on the navigator. So you just override the entire path in Kotlin. Now, if you want to display an overlay, such as dialog or sheet, the API is very similar. We again provide some API to our UI and some actions to call. And Jetpack Compose really easy, like no-brainer. However, Swift UI, like also easy, but you have to get into it. I believe there could be written some nice wrappers around this sometime in the future. Like we already had them, but I just will not show them because they're too complex. But whatever, yeah, like you get that sheet modifier in Swift UI. It's like really different from Compose, and it was mind-boggling for me at the beginning because like if you want to display a sheet in Swift UI, you have to call sheet modifier, and then you have to pass a state if it is like currently visible, as opposed to the Compose when you just like put your composable that displays the sheet. But yeah, like the state-wise is the same thing, just different execution. But yeah, like again, we get the binding, and in that binding, you have to get the state of if the sheet is currently visible in Kotlin. Like this means that this just like looks into the child slot and looks at the current child, and if it's not null, just show the sheet. And the set method actually gets called only in the case, and I hope that's true. iOS guys maybe correct me in the QA section, but like the only time the set is gonna get called is when you manually swipe the sheet off with your finger in the UI. So basically, you get this. You can basically like dismiss the sheet from the Kotlin side, and it will get hidden. But also, when you swipe it away with your finger, the set method will get called, which will again loop over to Kotlin, and the get method will read that, and it will hide itself. Yeah, really easy, right? Just works. So let's move on to arguments and results, because like with Jetpack Compose, we know that arguments are not the most funny part to do. However, in Jetpack Compose, in Decompose, two really similar words. In Decompose, the arguments are really intuitive and are type safe by design. What you basically do is that when you create your component is just a class that you have full control over. So you can basically pass your arguments and the lambdas that will get called as a result in the constructor, because it is your responsibility to create that component. And the Compose child stack uses keys to identify the components on that stack. And these keys are called configuration. In our case, it's this destination sealed class. And these configurations are stored on your backstack with your components. They sort of act as a blueprint to create your instance of the component. So what you can basically do is put some data into them, and then when you are creating your component manually in the factory, which you have to implement when creating child stack, you just pull the data of that configuration, that destination, and you pass them to your instance of your component. And as you can see, there's also like this lambda on button clicked, which we can call from that nested component, and it will bubble up, and we can react to it in this level of the child stack. I actually find it like a lot better than Jetpack navigation component because of this, because you have type-safe argument, and you can put basically almost anything. Like it has to be parcelable on Android, right? But yeah, it's type-safe. All right, this was pretty much the basics that you need to implement a shared navigation in Decompose. Let's go over some advanced cases. The first thing, I'm going to show just a few cases, but you should get the general idea of what is possible with Decompose. The first thing I'm going to go over is the stack observation, because since you are in full control over your stack, you can look into that, you can introspect it, and you can react to the changes of this stack. You can, for example, decide to hide the back button in your UI based on the number of children on your stack. And it's really easy. The stack is basically just a Decompose value which provides a state to a UI, because the stack must be observable from UI. So you can basically subscribe to it, map its value, and so on. It's really nice. The next thing is this monstrosity. Yeah, this took some time to like wrap my head around, but if you're iOS dev, you already know how to do this, but for the Android devs, what you basically need to do here is when you create your view in SwiftUI and you display a sheet over that view, you can actually embed another navigation stack into that view that is currently displayed in the sheet. And you can repeat that basically forever. So you just have like a view, sheet, navigation stack, sheet, navigation stack, sheet, and so on. And like on the diagram, it looks something like this, or in Decompose, it looks like this. You first have to create an empty slot, and in that slot you create a sheet. In that sheet you have another navigation stack of the children, and on the topmost children you just create another slot with the sheet, and you just like repeat it again and again and again, and basically this lets you implement this funny stuff. This is how would you model this situation in Decompose. I'm gonna let you sink in, because you have to really wrap your head around it, but once you get it, it's really nice, like that you have this possibility to do things. All right, multiple backstacks. Funny, like popular feature from Jetpack navigation. This might come in handy when you want to implement the bottom navigation in your application. And what you basically want to do is like you can leverage the fact that Decompose structures your components into tree. So basically, for each tab in your bottom navigation, you would switch the currently displayed node or like the leaf of the tree, basically. And since the Decompose components that are on the stacks are lifecycle aware. Each time you switch between these components or these views, then also your Decompose components that are not currently like active will get paused, basically. Now, in the root, you would usually display, each component has its own UI. And in the root component, which holds these 3 nested navigation stacks, you would display your bottom navigation. And in the rest of the UI, you would just handle the displaying of this nested navigation stack and all the children that are on top of it. This is handy. However, on Android, I totally forgot. No, I didn't forget to mention. I got kind of lost right now. Yeah. So this is how you would model that situation on component level. However, when you switch between the tabs and navigate back until there are no more screens on the current tab, you might want to take user back to any previous tab he might have opened, which this solution doesn't solve. And to do that, you just place your nested navigation components, like these navigation stacks, into another navigation stack. So what you basically do is that when a user switches between these tabs, each one of them has its own navigation stack. And when you perform that navigation, you just move the navigation stacks. You just like move the new to the front of this wrapper navigation stack, if you will. And so when you pop off all the screens of one of the stacks, what happens is that you're back to the previous one that you just have been at. And this can be done on Android. And I'm not sure if we got this on iOS or we just don't use it. I'm not sure. Yeah, but you can do it. So as a wrap-up, Decompose is cool. You can definitely implement this if you decide. You can definitely implement this using the native UI. Native meaning that users on iOS get this native feel and you still get to share your navigation. And you've seen that the sheets with embedded navigation stack of the sheets with embedded navigation stacks trademark just work. This was the most wild or complex part that we have implemented using this, and it was basically like the most advanced requirement from our iOS team, and we delivered, so we will be, I guess, using that in production soon. What are the benefits? Of course, you get a single source of truth for navigation. You might benefit from this if you have really large, complex applications, and it makes sense for you to share a navigation state between both platforms, or you just want to flex and share even more stuff in KMM. You get that benefit of being able to share presentation logic with Decompose. Yeah, this, like, you've probably heard that the Compose, JetBrains Compose is going multi-platform. It's in alpha for iOS. So if you are planning maybe to share also UIs in iOS in the future, this might be a next step for you. It would make sense to also share your navigation state if you are sharing entire UI in Jetpack Compose. Drawbacks. Yeah, what just I showed you was some, it was like really thinned out version of the code. Lots of parts were omitted because you get to write a lot of boilerplate with Decompose, because you always have to set up everything by yourself. There are no annotation processing and like this funny stuff. So it's really up to you, and you have to wire everything up by yourself. Decompose has a slight learning curve, especially if you want to onboard some iOS devs would be not really easy, but definitely doable. And yeah, you might know that the default interop between Swift or Objective-C to Kotlin, it does not look really good. And since we use a lot of sealed classes, you might know that these do not translate really well to Objective-C. So that might be a little bit of an issue, but nothing bad. So the question is, should you use it? Well, I encourage you to give it a chance, not because like I want you to share your navigation state, but because I think the Decompose is a really nice library, even without sharing the navigation state. But if you decide to share a navigation state, you should proceed with caution, because the navigation stack on SwiftUI is compatible only on iOS 16 plus, which means that you either have to cut off all your users that are using iOS 15, which is not a big issue, you know, like the adoption on iOS is really quick. But this is really solvable, because there are some interop libraries that you can use with navigation stack on older iOS versions, and we found them working pretty well. Pretty well meaning so far no issues, but you never know. Yeah, this is not also in production yet, so we are. Yeah, we're gonna like proceed with caution. Yeah, and yeah. Or it just might not fit your use case. You just do not want to share your navigation state, but now you know that it is definitely doable. So with that said, thank you. This is the QR code for the repository, which you can scan, and there is some basic example with implementation. So if you want, you can scan it now. There are gonna be slides after, so you will get to it sometime in the future, definitely, if you're interested. So thank you.